All right, welcome everybody. Today we're going to continue what we started, which is building the Elixir web console for Elixir and Phoenix apps that we will be able to mount into existing Phoenix app to provide IEX-like experience on the web. It's not going to be like complete clone because we could probably have hacked IEX to redirect it input and output, and maybe that would be better approach if we wanted to have the exact working, but I have something slightly different in mind that will, however, have very similar functionality that you'll able to execute Elixir code and see the results. And that actually largely works. What works now is not great yet, however, but let's see what we built last week. Mixdev starts the development server, and that's going to compile assets just like a normal Phoenix application, because it actually is very little development Phoenix application. And that's the user interface we built, and we can actually execute Elixir code. A plus B. So this thing works, and however, it has some issues. And those issues, in order that we will be fixing them, is that if something crashes, right? So I have undefined function here, the whole live view is going to crash. This is happening because for two reasons. One, that we're running the whole thing in the same process. So whenever something goes wrong, the whole user interface and the executor, everything just goes down and is being restarted. So that's the first issue. The second issue is we don't have the ability to use either imports or macros. So for example, if I had Ecto here, usually if I log into remote server and I want to access the remote console, I might want to inspect what's there in the database and use Ecto repo to do some queries, and I use this keyword, this DSL based syntax where you import ecto.query first thing, and we can't do that here. It's not gonna work. The same any macro, like if we require a logger and then try to use this logger, this is going to crash because it's gonna say that here somewhere it says that the logger is undefined, something like that. Undefined function, and then I'm gonna remove myself from the view. Terminate. You must require a logger before invoking the macro logger info, right? So this is not great. So those are two things. The third thing that I'm not sure if we're gonna get there today is that if you even manage to output something to the console, this didn't work, or did it? It didn't work here in the user interface, but it printed here on my terminal. So it doesn't redirect input and output actually to the web application, and we'll have to do some shenanigans with something that's called process group leader, which is the Erlang's interface to do input output to solve this issue. So those are three issues, and the fourth issue that we have to fix is that we can't do multi-line code foo, and that tries to execute this code, but it fails, and it doesn't figure out that this actually is looking for continuation. So we'll have to handle that error tuple here with this specific format. That means that basically there should be more Elixir code, and it hasn't been found. So we will have to handle that, buffer those lines, and then allow concatenating those strings behind the scenes for the user so that they can execute the module definition and stuff like that. Okay. Where do we start with those issues that we have? Well, we have this one view here that we have everything in. All right, this is our live view. This also executes the code, the command. So this is both interface and the backend. And that's part of the problem, that whenever something crashes here, everything crashes. And we don't want that. And in the future, we also want to start multiple of those backend sessions and disconnect our user interface and leave those sessions running. So it makes sense to lay some groundwork here to detach the code execution from the user interface. And let's actually probably start with that. Every Elixir application that defines OTP application has something that's called application callback module, and it usually lives in this lib name of the project /application.ex. And the reason for existence of this module is the start function, which in turn defines what was the supervision tree of this OTP application going to look like. And here it even starts this dynamic supervisor, which we don't use now. I'm leaving that in because we probably are going to use it to start multiple sessions. We don't need it for now, but since we're going to use it in the future, I'm leaving it here. What I want to declare here is that we're also going to start a single process for the code executor. In the future, when we have multiple sessions, this is not going to be like that. But for now, it's going to be good enough if we just start one code runner, let's call it code runner, and send, it's going to be a gen server, and we'll send the messages to it to execute some code. And the responsibility of that code runner is going to be preserving the environment, bindings, and also executing new Elixir code, plus catching errors, exceptions, and reporting back to the caller. Okay, let's call it code runner. And we also want to do some local name registration. Just register it for now as the same as the name of the module. Backdoor, okay, actually, yeah, that's correct. Code runner and code runner. And as I said, this might be just a simple gen server for now. And what do we have to define here? Since in our application we're passing this argument here, and I think we need to declare a startling function because it's taking the options. So startling with RT1 has to be defined here, and I think the default macro defines just one that doesn't have any arguments. And we'll start it with gen server start link, yeah, that's correct, module, and give it up. No, sorry, these are arguments to init, which we don't really care about now, and options, this is the name registration part. Okay, each gen server has like several sections. There's public API, right? There's callbacks, and I like to have also private or implementation details or whatever you call it. So for the so this starts, actually probably if we stop it and start it, this is going to start it already. Yeah, I think it does. So it doesn't crash. The application didn't crash. Means our code has been code runner has been started, but it's giving us this warning that I just lost. That the init function, the default implementation is provided. Okay, and actually we need this init function, and I think it's actually a callback because it's been provided by and expected to be there by the behavior. So that's implementation true, and I have init. We don't really care what's the argument here, so ignore this initial state that's being passed, and we return OK and the state. And again, I said that this thing has to keep track of two things. One is going to be bindings, and as we declared it here in our live view, those bindings are empty list. I'm going to remove it from here and add it here, right? But the second thing that our code code runner has to keep track of is something called environment, and I'm just gonna call it env, and this has to be initialized. So I'll add a function to initialize environment. And I actually had a look at the elixir IEX lib IEX, and there's I think called evaluator. Yeah, evaluator. And I had got some tips from here since the last view on how we can use the macros. So there's a function somewhere here. I think it's called doExec or exec eval. We'll guess it at some point. Yeah, so here we go. This is the env, and it has to be initialized with something like env for eval, which we're going to copy over to our code runner, to this private function init env. So what it does, we can try in IEX. Oh, that's not this thing. One more time. IEX elixir env for this part. Yeah, so this initialize that thing where you can where it stores the aliases, functions, imports, requires, so all of those things that are needed for more fully functional Elixir environment to work. So in order to make our imports and requires work, we need to initialize that thing. And it also, by looking at this evaluator, I figured it does execute Elixir code slightly different than what we do here. So far we've been using this code, where is it? Code eval quoted function, and it doesn't take this environment, and that's the problem, right? So it doesn't take the environment to store the requires, imports, and etc. So we have to use different function, something with forms, eval forms. Here we go. So that's what is being used in IEX, and we are going to use the same thing here to actually execute the code. So for now, I'm just gonna put it here as a note. Okay. Right. Now, from our live view, I no longer want to do that. So I'm going to remove those two things, and I'm going to add it here as a note as well. So we're removing that code, and instead I want to call our code runner with this code. So actually we probably want to do it in a way that first I'm gonna find a PID for our code runner, so we can call it. And now, once we found it, we can do something like execute pid and command. Yeah, and this will give us the result. Or even better, we can have OK result, right? And now there are things here that we don't need. Output. I actually don't like that we're using IEX here anymore, because this is not IEX. That's separate application. So we don't want to have conflict here. And this is the result. We just inspect the result here. Okay, that's so far so good. Socket command. Okay, we removed bindings from here. So this will execute this command, and we, in case of success, we're gonna get OK result. Okay, let's add it to our public API. Runner, that's going to PID and the code to execute, and then server call runner execute code, for example, something like that. And we have to provide the callback for that. Def handle call, I think it is. And the same tuple, execute code. We don't care who's the caller, and our state. The state is what we just initialized here. So for now, that's a map. Okay. And here we actually need those things. We need AST, which is the Elixir abstract syntax tree. Okay, so this means that it's been parsed, and that's fine. And then we're not using the old function, we're using the new function that we stole from IEX itself. Okay, so we got result, binding, environment, eval forms. We could be matching here, but I will just return it to the caller and do the matching there. So, or not. I have to think about that. This handle call, no, because we have to return something like reply, OK result, right? And then we have to update the state. So we have the last state and update it with bindings and update the environment, because environment, similar to bindings, after each code execution has to be saved. Okay, that looks fine. And it returns OK result, OK result, OK result. That looks good. Let's see. So I'm going to restart the whole thing. No, that would be too good to be true. Code runner 23, undefined function command, undefined function command, because I renamed it. It's going to be code and the state binding, and this goes, also that's wrong, state environment, and I think that's fine. Nope. This code runner 24 quoted, yeah, because I just copied over the code, and this is abstract syntax tree, AST. Bindings, code runner 26, bindings, okay. Wow, it started. Let's see whether that actually works. So for now, there's no functional change. Actually, no, there is functional improvement. We can use macros and imports if that works. Actually, I can probably just logger. Oh, okay. If I can type logger info foo. It printed out foo. That's my previous typo, right? So one more time, I'll restart it. Require logger, that's fine. All right, so we moved it out to the separate module, started it under supervisor, and we also made macros and imports work. That's great. Great success. Now, the second thing which we can solve here is the exceptions. Actually, I have something open here that I don't think I need. Okay. And yeah, the errors, the exceptions. I again had a look at the IEX, and what it does here is just to wrap things into try and catch. And that's good enough for them, and that has to be good enough for now. That doesn't make we can't break it. Like I can break IEX, for example. We'll start IEX, and I think we can break it, for example, by exiting the code evaluator, or yeah, I think we can break it this way, like process exit self with something like that. Yeah, so it broke it. So the whole thing restarted, right? So, but in cases of other, like just something undefined, it doesn't crash it, so that the declared variables, they remain the same, etc., etc. So unless I do something like process exit, the IEX handles the errors for us, and that has to be good enough for us for now and probably forever. So okay. So actually, I don't need that here anymore. No, I do need that. Right, I do need that, but in the code runner here, we have to wrap this whole thing up into the try and catch. How is it? Try catch and this kind error thing here. For now, we're not messing with any paths, etc., etc. And this is just going to okay, so first thing first, in case of success, we're moving that here. We're returning OK result. And in case of error, we're going to return something like error kind, the message itself, and possibly also the stack trace. And we don't want to update bindings on our environment because the last message was error, so there's nothing to update. So no variables changed. Actually, that's not how you. Oh, here we go. That's better. Okay, so that's catching the error, but it's still not gonna work good because we're returning OK error, but not handling it in the user interface. So here, if I actually have an error, it's still going to crash and restart the whole thing because no match for right hand side error. Yes, that's the error. And the kind was error. Okay, so OK error, we have error. We don't have to do that. That's too much, I think. So we just need to return like kind error and stack trace I think. Okay. All right. So there's two possibilities. One is that we're going to receive OK result, and that's our happy path. And in this happy path, we are going to return the result. Actually, that's the value. We can call it something like that might be something like formatted result or error. I don't know. Maybe I'll find a better name for it. So formatted result or error, inspect result. I think that's cool. Else, in case of error, in case of kind error stack, I want to format that error, and in Elixir we have a handy function that allows us to format it, and I had it bookmarked somewhere. I think it's exception format. Is it exception format error? Let me just double check it quickly in the browser view. Yes, it's exception format, kind error stack trace. Easy. Okay. And this is different name. Okay. Did we do it? Did we do it? It looks good. Wow, it compiled. Okay. Okay, let's have a look. A equals 1, B equals 2, A plus B. That still works. Something I need to find. Compile error. That's been printed. That's great. A, B, A plus B. Awesome. And our logger. Okay. So this is macros work, but the input output still doesn't work as expected, and we can't write multi-lines. But I think that's enough for today. So I think we can wrap this up. I think that's good. We can wrap this up. In the next episode, we will be covering the input, actually the output redirection, so that we can capture. Probably what we're going to do is to replace the group leader, the output interface in Erlang, to print the output to the console. And then we can also tackle the issue of multiple lines that the user enters, so that they can, like, not just one-liners, but a better Elixir code. And then we'll move to making multiple sessions and make those sessions last longer than the live view, so that if something disconnects, the code keeps running on the server and user can go back to their session. All right. Thank you for watching and see you next time.